Hello everyone, welcome to my YouTube channel. I am Jugnu Choria and this is the second video tutorial of our series Let's Learn C++ in Best and Easy Way. If you have not watched my previous tutorial video, I recommend you to please watch it first, as in that video we have discussed two important terminologies of C++, that is keywords and literals. You can watch it by clicking on the I button that is on the right corner of your screen, and also I have provided the link in the description so you can check it. Now this video is the continuation of that video. As you can see in the screen, we have discussed keywords and literals, and now in this video we will get to know about identifier, operator and punctuators. So let's start with this video. Now starting with identifiers we can understand as these are the names created by us for naming variables, functions and other similar entities in C++ programming language. As in programming, when we make use of variables functions, we declare them with a certain name. So this name is called as an identifier. Now here comes the important part. There are some set of rules for making identifier in C++ that we're gonna see now. Now one note here, that if you're watching this video, so you can note anywhere these rules, so please note it, as it is very important for you to memorize it. Now starting with first rule, identifier can be created using alphabets or digits. For example, as you can see in the screen, variable 1, var 2, var 3, these are valid identifiers that we can create for naming variable functions, etc. Now coming to second rule, that is the only underscore is a symbol which is allowed in an identifier. A special symbol other than underscore is not allowed for creating identifier. For example, as you can see in the screen, and @var is not a valid identifier. Similarly, #var is not valid. Now what is valid is var underscore 1, var 1 underscore, these can be valid identifier. Now coming to a third rule, that is an identifier cannot begin with a digit, but it can begin with alphabet or underscore. For example, as you can see in the screen, 1 var, 2 var, these identifiers are not valid. As you can see, these are containing numbers at the starting, that is 1 and 2. Now let's see some valid examples. Underscore var 1 underscore 2, these are some of the valid examples. As we have seen, underscore can be written at the starting while creating an identifier. Now coming to our fourth rule, C++ is a case sensitive language, so it distinguishes between small and capital letters. For example, here var and var are different. As in second var, V is capital. I hope you understand these. Now coming to our fifth rule, identifier cannot be identical to keywords, but keyword can be part of an identifier. Now in previous video, as we have discussed about keywords, those who don't know about keyword can visit my previous video, the link is in description. Also you can visit by an I button. For example, int is a keyword. Now we cannot make an identifier as an int, as because it is predefined in a compiler that it is a keyword. It has certain declarations. But we can create the identifier name as int1, int underscore 1, underscore float, as float is also a keyword. So here we can use keyword as a part of an identifier. So it is valid. But as it is keyword, we cannot use it for making identifier. So these 5 rules are very important for making an identifier. So here we end up with an identifier. Now coming to our next topic, that is operator in C++. Operators, as the name suggests, their work is to operate. Now on what they operate? So basically operator operates on operands. coming to definition, operators are special symbols which performs one specific work on operands. Let us understand these terms operator and operands with an example. Suppose we calculate a plus b. So here a and b are working as operands, and the plus sign in between is a operator. And here the operation performed by operator is to add both the operands, as the plus sign signifies addition. So similarly here we will discuss operators in C++. On the basis of number of operands an operator can handle, the operators are classified as unary operator, binary operator, and ternary operator. Similarly, on the basis of the work they perform, the operators are classified as arithmetic operator, assignment operator, relational or comparison operator, logical operator, conditional operator, and then last bitwise operator. So let us understand this one by one. Now coming to our first category division, that is on the basis of number of operands an operator can handle, starting with unary operator. As the name suggests, unary means one. So these types of operators can handle only one operand. For example, there are increment and decrement operators in C++. These are unary operators as it work with only one operand or any one variable. For example, we initialize a variable a with 5 and we apply the increment operator, as you can see in the screen, a plus plus. So here what it does it that it adds 1 to the variable. So now the variable is incremented with 1, so its value is 6. Similarly, there is a decrement operator. So in the decrement operator, it subtracts 1 from the variable with which it's applied. So as for example, we applied it with a, so the present value of a is 6. Here we write it as a minus minus. So here minus minus signifies the decrement operator. Now here a will be subtracted by 1. So the current value of a will be 5. So as we have seen, this works with only one variable and no second variable is used here. Coming to our next topic, that is binary operator. Now as the name suggests, by means 2. So this operator operates two operands. For example, a plus b. Here a and b are two operands and plus is an operator. So this plus cannot work with one operator. It requires two operators to work. Similarly, a asterisk b, a slash b, a minus b. Here all these asterisk, slash and minus, these are working as a binary operator. I hope you understand these. Now coming to our next operator, that is a ternary operator. The ternary operator operates with three operands. So here you will be thinking that how an operator can work with the three operands. So in C++ there is a operator, or there is a method in which operator works with three operands. So the question mark operator, that is also called a conditional operator, works with three expression. As you can see in the screen, the syntax is there. So condition question mark expression 1 colon expression 2. So here what it means, let us understand this with an example. As you can see in the screen, we have written a greater than b question mark a is equals to 2 colon b is equals to 3. So here what it means is that suppose a is equals to 5 and b is equals to 6. Now here a greater than b is the condition. So if this condition is true, then the expression 1 will be executed, and if it is false, then expression 2 will be executed, that is b is equals to 3. So here a is equals to 5 and b is equals to 6. So 5 is greater than 6, so it is false. That's why here second expression will be executed, that is b equal to 3. Here we finish with ternary operator. Now coming to our next category division of operators, that is on the basis of working of operators. Here it is divided in 6 categories, as we have seen. So let's start with arithmetic operators. Now as the name suggests, arithmetic means to do some mathematical calculation like plus, minus, divide, into. So here we will see there are 5 operators in arithmetic in C++. Now here, as you can see in the screen, plus operator, as we know, it is for addition, minus is for subtraction. Now star, it is called asterisk, it is for multiplication. Then there is a slash operator is for division, and the last is percentage or modulus operator. This is new for you. So basically modulus operator calculates the remainder when it is executed. Suppose we write a percentage 5, and for example a is equals to 2 and b is equals to 1. So 2 percentage 1, when we divide 2 by 1, then what will be the remainder? So basically what it calculates. Now on dividing 2 by 1, we will get remainder as 0. So here on execution of a percentage b, we will get 0. Now here one important thing to remember about division operator. Now here when a division operator is executed and the expression is initialized to some another variable, then the result is dependent on that variable data type. And now suppose we declare a variable r of int data type and initialize it with 10 by 2. So here r will be equal to 5, as 10 by 2 equals to 5. But when we will initialize it with 11 by 2, then also it will be equal to 5. But 11 by 2 is equals to 5.5. But the r will be initialized with 5 only, as because the data type of r is int. And suppose we declare variable r with float data type. Now here when we will initialize it with 11 by 2, then here r will be equal to 5.5. So here it is very important to remember this, that the result of a division operator is dependent on the resultant variable in which it is executed or initialized. And now coming to our second operator, that is assignment operator. Now here also, as the name suggests, assignment means to assign. So this operator is used for assigning values to the variables. As in maths we use equals to operator. This is also an assignment operator. Now here we will see some basic but very important rules that we have to keep in mind while using assignment operators. The variable in which we are assigning the value should be always present in the left side, and the value which is assigned will be on the right side, as you can see in the screen. As here I have written a is equals to 5, so here 5 will be initialized to a, so a will store 5. Also here it is very important to clarify your concept that when we write in maths a is equals to b, then it means that a is equals to b. But in programming, when we will write a is equals to b, then it says that store b in a, that is the store the value of b in a. Suppose b is equals to 2 and we initialize a is equals to b, so we are storing the value of b, that is 2, in a. It is not saying that a is equals to b. Okay, now let's see types of assignment operators used in C++ language. As you can see in this screen, is equal to is the very basic assignment operator. Then there we have a plus is equals to, then minus is equals to, asterisk is equals to, slash is equals to, percentage is equals to, that is a modulus operator, modulus is equals to. So what does they mean? Let us understand this with an example. Suppose we write a plus is equals to b. So here what it is describing is that actually it is a short form of a is equals to a plus b. So whenever we are initializing same value and performing some expression, arithmetic expression to it, then we can write it as in short way, that is plus equals to, asterisk equals to, slash equals to, or modulus is equals to. As you can see, all these are defined in the screen. So I hope you understand these. Examples are also there. Suppose we write a plus equals to 2, so here it is defining a is equals to a plus 2. Suppose a is equals to 5, so a is equals to a plus 2. So 5 plus 2, that is now A is 7. Hope you understand assignment operator. Now coming to relational operator or comparison operators. Now as you can see in the screen, these all are called relational operators. These are used when write some condition. Suppose we write A is greater than B, A greater than equals to B. So here greater than equals to is written as you can see in the screen. As you can see the examples in the screen. So when these conditions are implemented, so they return some values, that is in the format of 0 and 1 only. Suppose if a condition is true, so it will return 1, and if it is false, 0. Suppose we write a condition 5 is greater than equals to 5. So here it is two conditions, greater than or equals to. So 5 is equals to 5, so it is true, then it will return 1 to the compiler. And suppose if you write 5 greater than 5, as 5 is not greater than 5, so it is a false condition, so it will return 0 to the compiler. So these are same operators as we use in maths for defining conditions, but there are two different operators as you can see in the last, that is double equals to and the exclamation mark and equals to. So the exclamation mark here is called not operator, so here it is meaning not equal operator, and the double equal operator is called as equivalent operator, as it checks for two values that they are true or not, and if they are true, that then it returns 1, and if it's not true, then it returns 0. For example here we write 5 equivalent 5, so here 5 is equals to 5, so it will return 1 as it is true. And similarly not equal operator checks for the values that it is not equal or not. If it is not equal, then it gives true, that is 1 to the compiler, and if it is false, that is if the values are equal, then it will give out 0 to the compiler. For example, we write 5 not equal to 6, so here it will give 1 to compiler as it is not equal to 6. And if we write 5 not equal to 5 as it is equals to 5, so it will give 0 to the compiler as it is the false condition. I hope you understand the concept of equivalent operator and not equal operator. So here we end up with the conditional operator. Now coming to logical operators. There are mainly three types of logical operators. These are AND operator, OR operator, and NOT operator. Here in C++, the AND operator is represented as two ampersands, as you can see in the screen. This mirrored cursive S are known as ampersand. You should know the name of these operators. So these two ampersands are treated as AND operator, and the two pipes, parallel pipes, are treated as OR operator, and the exclamation mark is treated as NOT operator. Now where to use them? Let us understand this with an example. Suppose we write a conditional expression, that is 5 greater than 6, 2 ampersands, 6 greater than 5. So here we have used two conditions, that is 5 greater than 6 and 6 greater than 5. Now 5 greater than 6 is false condition, so in the compiler it will return 0, and here we have used two ampersands, that means AND. Now in second condition there is 6 greater than 5, which is true, so here the compiler will return 1 here. So actually what is written here is 0 and 1. Now AND operator specifies that if it is used with any two condition, and if any of one condition is false, then it will return false. Any conditional expression with AND statement will return true only and only if both the conditions are true. If any of the condition is false, then it will return only false. And in case of OR operator, when it is used with any two conditions, then it specifies that then if any of the two condition is true, then it will return true, and it will return false only when both the conditions will be false. Coming to NOT operator. Now the work of NOT operator is to complement an expression and variable with which it is used. Suppose we make a variable a is equals to 1 and write not a, so the value of not a will be 0. Similarly, as you can see in this condition statement also, we have initialized b is equals to not 6 greater than 5. Now here 6 greater than 5 is true, but here not operator used with that condition, so it will complement the condition, that it will opposite the condition, so it will become false. So the variable b will be initialized to 0. Now this is all about logical operator. Now coming to our next topic, that is conditional operator. Now conditional operator, already we have seen in ternary operator, both are same. As you can see in the screen, question mark operator, it is called conditional operator as well as ternary operator. So now coming to our next topic, that is bitwise operator. Now here, as the name suggests, bitwise, so these operators mainly deals with bits. So what is bits? Bits is a binary digits. Basically bit is a short form of binary digit. These operators work on the binary equivalent of the integers that we initialize to any variables. So suppose we initialize a variable a with 5, so here binary equivalent of 5 is 101. Whenever we will use these operators, bitwise operators, then they will operate on the binary code of an integer. Now here, as you can see in the screen, there are 6 types of bitwise operator. That is, the first one is bitwise AND operator, second is bitwise OR operator, third is bitwise XOR operator, then bitwise complement operator, bitwise shift left operator, then bitwise shift right operator. Now let us understand these one by one. Now here, as we have understood the concept of and or in the logical operators, that if and is used with any two condition, then both the condition will be true, then only it will return true, and if any of one condition is false, then it will return false. And similarly in case of or, when both the condition will be false, then it will return false, and any of one condition will be true, then it will return true. Also, let us understand this with a numeric example of 0 and 1 with the help of truth table. Now, what is truth table? As you can see in the screen, truth tables of and, or, XOR, not. Now here in and truth table, let us suppose 0 is false and 1 is true. Now here false is false, then 0 1, that is false true is also false. As I have told that if any of one condition is false, then the resultant is false. So here 0 1 is 0, also 1 0 is 0, only 1 1 is 1. Only when two condition will be true, then it is 1. Similarly in case of or, here 0 0 is 0, 0 1 is 1. As any one of will be true, then the resultant will be true, and 1 0 is also 1, and 1 1 is also 1. As both conditions are true, so the resultant is also true. Now here, these all we are studying here is a Boolean algebra concepts. So when you will get into Boolean algebra, then you will know that and is represented as dot and or is also represented as plus. Now coming to XOR operator. Now the meaning of XOR operator is that when we pass two condition to this operator, then if any one of the condition is true, then only it returns 1. If both is false or or if both is true, then it returns false. As you can see here, 0 0 is all 0 and 1 1 is 0, but 0 1 and 1 0 is 1, that is both are true. So if any one of the condition is true, then it gives out the output as true, and any if both are true and both are false, then it gives out false. So this is all about XOR operator. Now not, as we have seen, it complements, so it will convert 0 to 1 and 1 to 0. Now let us implement the bitwise operator one by one, starting with the bitwise AND operator. as its sign is ampersand, 1 ampersand. Suppose we make a variable a is equals to 5 and b is equal to 6. Now we initialize another variable c is equals to a ampersand b, that is bitwise AND operator. Now what will be the value of variable c? Let us see. Here, first of all, we will convert a and b to its binary equivalent. Now the binary equivalent of 5 is 101 and the binary equivalent of 6 is 110. Now here we have converted these integers onto their binary digits. So now we are on the bit level. So we will perform the AND operation on every binary digit. So as you can see in the screen, first of all we will perform with 1 1. Now here 1 and 1 is 1. Then 0 1. Now 0 and 1 is 0. Then 1 and 0, that is 1 and 0 is 0. So the resultant binary code we get is 100. Now then we will convert it to its decimal equivalent. Its decimal equivalent is 4. So the resultant will be initialized to C. The value of C is 4. I hope you understand the concept of bitwise AND. Now coming to bitwise OR. Taking same example, a is equals to 5 and b is equals to 6. Now here what we will do, we will apply OR operator to single binary digits. So here 1 or 1 is 1, 0 or 1 is 1, and 1 or 0 is also 1. So here the binary code we get is 111, and the decimal equivalent of 111 is 7. So the value of C will be 7. Now here the OR operator uses pipe as its sign, so remember it, and hope you understand the concept of bitwise OR. Now coming to next operator, that is bitwise XOR operator. Now as we have seen in the case of XOR operator that if any one of the condition is true, then it gives out the true, and if both are false and both are true, then if it gives false in both these condition. So here with the same example, a is equals to 5 and b is equals to 6. Now here if we implement XOR operator on every bit, we get 1 XOR 1 will be equal to 0 as both are true. Then 1 XOR 0 will be equal to 1 as one of them is true. Then 0 XOR 1 will also be equals to 1 as one of them is true. So the resultant we get here is 0 1 1, and the decimal equivalent of 0 1 1 is 3. So the value of C here will be 3. Let us take one more example for a bitwise operator. Suppose a is equals to 4 and b is equal to 6. Now the binary conversion of 4 is 100 and 6 is 110. So when we will apply bitwise OR, so here we will get now 1 XOR 1 is equals to 0 as both of them are true. Now here 0 XOR 1 will equals to 1 as one of them is true, and 0 XOR 0 will equals to 0 as both of them are false. So the binary code here we get is 010, and the decimal equivalent of 010 is 2. So here now the value of C will be equal to 2. So here we end up with our bitwise XOR. Now coming to next operator, that is a NOT operator. So NOT operator is pretty much simple, as it will complement the binary code of the given integer. Suppose a is equals to 4, then the binary code of 4 is 100. Then if we apply not operator to variable a, as you can see in the screen, not a, so here it will complement it, the binary code. So the complement of 100 is 0 1 1. So here 0 1 1, the decimal equivalent of 0 1 1 is 3. So C will be equals to 3. Now coming to our next operator, that is bitwise left shift operator. Now while using this operator, the changes is made on the first operand. As you can see in the screen, a is equals to 4 and we have written a left shift operator, then 3. So what it is going to do is it will add 3 zeros at the end of binary code of a. Now here binary code of 4 is 100, so it will add 3 zeros at the end, so that binary code will become 100 and 000, and its binary equivalent is 32. So here we can say that a is changed to 32 from 4. Now when you will see the binary code, so it is the previous binary code, that is 100, is looking as that it has shifted to left side from 3 digits. Now here in the right shift operator, it deletes the number of binary digits from the last as we specified. Suppose we write a right shift operator 3, so it will delete 3 binary digits from a. So suppose we write a right shift operator 2, so here suppose a is 4, so now it will delete the last 2 elements of its binary code. As its binary code is 100, so the 00 will be deleted, so new binary code is 1. So now a will be equals to 1. Hope you understand the concept of the bitwise operators. So here we end up with our operators topic. Now coming to our next topic, that is punctuators. In English language we use punctuators for punctuation. Similarly, here in C++ programming we use English punctuators, but their meanings and their work is different in this programming language. So for example, here you can see the semicolon is used as statement terminator, comma as separator, dot as member of operator, colon as label maker, question mark as ternary operator. It is also known as conditional operator, double colon as scope resolution operator, double quotes as a string maker, single quote as character maker. These punctuators have certain meanings in C++. There are many more. As we will learn to code, we will much more learn in detail about these. So hope you understand the concept of punctuators in C++. So here is the end of our. So let us see what we have studied in this video. First of all, we have discussed identifiers. Then we have seen set of rules for making identifier. Then we have seen operators. Then we have seen operators, types of operators in detail. And then last, punctuators. So if you like the content of my video, please do subscribe my channel and do click on like button. Also click on notification button, so you will be notified whenever I will upload my videos, and do share with your friends. Thank you for watching.